In this video segment, we will be talking about the reactions involving amines and amides. If you can recall from the previous lecture, we have learned that amines are actually basic and they can react with acids. Hence, when we react amines with acids, we will form an ionic salt, which is actually soluble in aqueous solutions due to the ion-dipole interaction that can be formed. And on evaporation, we can actually obtain these salts as white crystalline solids. So this acid-base reaction is actually quite useful as we can make use of it to separate amines from other organic compounds. So in this setup here, which is also on page 94 of your lecture notes, you will see that there's actually a mixture of two different compounds. One is a cyclohexane and one is a cyclohexane which has a extra amine functional group. So when I add HCl aqueous into this mixture, what happens is the amines will actually be able to have an acid-base reaction with the HCl, forming this ionic salt. And the ionic salt is actually soluble in the aqueous layer due to the favorable ion-dipole interactions with water molecules, whereas the cyclohexane will remain insoluble in the aqueous layer. Hence, using this separating funnel, we can actually separate out the two different immiscible layers into two separate conical flasks. And with this aqueous layer, we can actually regenerate the amine through another acid-base reaction by adding a base to the conjugate acid of the amine group to get back our amine. Another important reaction is the reduction of nitrobenzene to phenylamine. So these are the reaction conditions and reaction reagents that are required. Adding on to the reduction reactions, the reduction of amides are also important in lithium aluminum hydride in dry ether. The next important reaction of amides is the hydrolysis of amides in both the acidic and alkaline medium. So take note, if you are using the acidic reagents, which is the dilute sulfuric acid, you will actually get the carboxylic acid and the ammonium ion. However, if you are using the alkaline medium, which is the dilute sodium hydroxide, you will get the sodium salt of your carboxylic acid and ammonia. A point to note is that if you are hydrolyzing an amide that is not a primary amide but a substituted amide, you will actually get an amine instead of an ammonia molecule.